Hello grade 11, how are you today? Hope you're doing fine. So in this video we're going to continue talking about Newton's law, okay? In the previous video I talked about the first Newton's law. Today we're going to focus on the second Newton's law, or basically we're going to work using this formula. Force is equals to mass over acceleration, and then we're going to explore what does that mean, okay? So let's go. So Newton's second law. Let's just remind what's the first law. In the first law, we didn't have acceleration, or my acceleration is 0 meters per second to the square of 2, right? Now in the second law, I have acceleration other than 0. So I have acceleration that's not 0. That's the main difference between these two laws. So the first question you need to ask is, the force in my problem are balanced or not balanced? If they are balanced, if your answer is yes, they are balanced, then we are going to talk about acceleration of zero. Because if my forces are balanced, it means I don't have any balance to change my movement. So my acceleration is 0. If my acceleration is 0, I can have two situations. I can be at rest. If I'm at rest, my velocity is 0, and what's going to happen? My velocity remains at rest, because if I don't have any force acting, my velocity continues to be 0. So if I'm at rest, I don't have acceleration. Why? Because I don't have any force acting. If I don't have any force acting, my velocity will keep the same as 0. But if I'm at motion, it means I have a velocity, can be any. Here I put an example as 2, but can be any velocity. And if I don't have acceleration, what's going to happen? My velocity will continue at the same. So it's going to be 2 meters per second. You keep the same. But if my forces are not balanced, what's going to happen? I have acceleration other than 0. Then we need to calculate the acceleration, the velocity, and everything. Which of them is the first Newton law? The answer for yes or the answer for no? The yes. So the first Newton law is dealing with the acceleration equals to 0. But if my acceleration is not 0, then I'm talking about the second Newton's law. That's what I'm going to focus in this video. Okay, so let's go. Newton's second law. It states that the resultant force, or Fr, exerted on a body is equal to the product, so multiplication, of mass of this body and its acceleration. So putting mathematically order, resultant force is equal to mass times acceleration. So my resultant force, how do I measure force? Always in Newton. How do I measure mass? In kilogram. How do I measure acceleration? In meter per second square. So I need to use this unit, okay? So if it's not in this unit, you need to convert. So acceleration is directly proportional to resultant force. What does that mean? If I have more force, I'm gonna accelerate more. So the more I increase the resultant force, the more I have acceleration. So they are directly proportional. And they are in the same direction. So if I'm going up with my force, my acceleration also goes up. If I'm going down, also goes down, and so on. But acceleration is inversely proportional to mass. What does that mean? It means that if you have a bigger body, a bigger object, you need to give more force. And if you keep, for example, I have two objects, one is small, while the other is big, and I apply the same force for both. If I apply the same force for both, they're gonna move in the same way? No. If I have a bigger object, it's gonna move less if I apply more for the same force. Okay, that's why it's inversely proportional. If I have more mass, my acceleration will be less. I have less acceleration. It's gonna move less. So now we are talk about forces that are not balanced. So my acceleration is not zero, and my acceleration is directly proportional to what? To force, the resultant force, and inversely proportional to my mass. So if I don't have, if my forces are not balanced, my acceleration is different of zero, which means it is directly proportional to the resultant force and inversely proportional to the mass. If I increase my force, I increase my acceleration. But if I increase my mass, I decrease my acceleration. That's why it's inversely. Let's do some examples. Here I have a table with some information about the resultant force and acceleration of a specific body. Doesn't matter. In this case, all the mass are the same. Okay, so I'm not changing the mass at all. Let's compare the example 1. Compare trial 1 and 2. My trial 1, I have a force of 20 newtons and my acceleration is 4 meters per second squared. In my trial 2, I have force of 40 and my acceleration of 8 meters per second squared. What can you say about these two? How can you compare these two? What happens to my force from 1 to 2? It doubles, right? So it was 20 and now it's 40. And what's going to happen to acceleration? Also double. It was 4, now it's 8. So if I double my resultant force, my acceleration also double. So that's what I could observe in first trial 1 and 2. Now what's happening between trials 1 and 3? My trial 1 is 20 of force and my trial 2 is 60 of force. What's happening from one to the other? How much it decreased or increased? It increased 3 times, right? It was 20, now it's 60. What happens to acceleration? It was 4 and now it's 12. How much it increased? Also 3 times, right? So I have, if I triple my force, I also triple my acceleration. So triple force, triple acceleration. So they continue to be directly proportional. Let's compare now the 1 and 4. 1 was 20 of force of 20 newtons and 4 is 10. What happened? It decreased by half. And what about acceleration? It was 4 and now it's 2. What happened? Also decreased by half. So if I half, I put it's like half of my force is going to be also half of my acceleration. Conclusion: by whatever factor resultant force is changed, A changes by the same factor. If I double my force, I double acceleration. If I halve my force, I halve the acceleration, and so on. So they also, when I change my force, my acceleration also change with the same factor. This means acceleration is directly proportional to resultant force. Okay, let's compare now mass and acceleration. First, let's compare in this example 1 and 2. 1 and 2. Here, I'm keeping my force the same, okay? So I don't change the force. I'm changing the mass and the acceleration. If my mass in the first trial was 4 and now it's 8, what happened to my mass? It doubled, right? And what happened to my acceleration? It half. Here I double, but here I divide by 2. I half it. So In the first, compare 1 and 2, I double mass, but what happened to my acceleration? Becomes half. Let's compare now 1 and 3. It was 4 kilos. Now I have 12. What happened? It increases by 3 times, right? Triple. But what happened to my acceleration? It was 12, now it's 4. It decreased by 3 times. So here my mass increased 3 times, but my acceleration decreased 3 times. So while if I triple my mass, I have 1/3 of acceleration. And then the last one, 1 and 4. Compare 1 and 4. So I have 4 and 2. What happened? Decreased by half. What happened when I compare the acceleration? It was 12, now it is 24. It increased by double. When I make my mass by half, I double the acceleration. So if I'm applying the same force, what's going to happen to my acceleration? It's going to double. In conclusion, by whatever m factor is changed, a also changed by the reciprocal factor. What's the reciprocal factor? Now it's not the same factor, it's the reciprocal. It means that if I decrease, I increase the other one. If I double, the other halves, okay? And my acceleration is going to be inversely proportional to mass. Okay, let's do another example, ranking the objects by A to D according to acceleration. So let's see an example here. Here I have 4 situations, A, B, C, and D, with different force, with different mass. I want to rank the objects A to D according to acceleration. Okay, so let's find out the lowest acceleration and the highest acceleration. Let's look between these 4 examples, which one has the biggest force but the smallest mass. Let's see the force. Who has the biggest force? So A has 10, B has 60, C has 30, and D has 10. Who has the biggest one? The B. So B has the biggest one. And who has the lowest mass? The smallest. A has 10, B has 2, C has 10, and D has 20. So who has the smallest? B also has 2 kilos. So what does that mean? If I have the biggest force, I'm going to have the biggest acceleration as well, right? So B is going to have my biggest acceleration. What's going to be the acceleration? I just divide the 2. I'm going to do this after, okay? So 6 divided by 2 is 30. Who has the second biggest force? So A has 10, C has 30. And D has 10. Who has the second biggest? So C has 30, right? So C is going to be the second one. If I calculate the acceleration, it's going to be 3 meters per second. And now, A and D has the same force. So both of them has 10 newtons of force. If both of them has the same force, I need to look for the mass. Who has the smallest mass? Who has the smallest mass is going to have the biggest acceleration. So A has 10 and D has 20. Who has the smallest mass? A. So A is going to be the acceleration as 1 meter per second square. And the last one, the same force but the biggest mass, is going to be D. So it's going to be the acceleration 0.5 meters per second square. So B has the highest acceleration, followed by C, followed by A, followed by D. Okay, let's do some math now. Determine the resultant force and acceleration of a 3 kilos object whose force diagram is below. So here I have this diagram. The first step I need to do is calculate the resultant force. Let's look over there. How do I calculate the resultant force? Just like we did before. Here I have 30 newtons up and 30 newtons down. So they cancel each other, right? If I have the same force pushing up and pushing down, the resultant force is going to be 0. So I don't need to worry about them. But now I have from left to right 36 and from right to left 24. How is going to be? 36 minus 24. So my resultant force is 12 newtons. Now that I have my resultant force, I have the resultant force 12, and I have the mass 3 kilos. And then I can replace my resultant force is 12, my mass is 3, and I can calculate my acceleration. So my acceleration is going to be 12 divided by 3, 4 meters per second per square. Okay? Okay, so let's do the last exercise, okay? Example 8. What's the direction of the acceleration on each case below? Calculate the acceleration if the object weighs 1 kilo. So let's see the first one. Here I have a diagram, and in this diagram I have force going up, going down, going left, going right. So the first thing I need to do is calculate the resultant force. So which should I word here? For up, I have 25 newtons, down 25 newtons as well. So they cancel each other. I don't need to worry about that. How do I calculate now the resultant force? I have 25 going right and 15 going left. So what's going to be my resultant force? 10 newtons. Going where? From left to right. With this information, I can calculate my acceleration. Remember the formula? The resultant force is equal to mass times acceleration. So I have a resultant force of 10, my mass of 1. Remember 1 kilo here. So my acceleration is going to be 10 meters per second to the square of 2. What's going to be the direction of my acceleration? Also the same, left to right, the same as my resultant force. Okay? The second situation, I have here 15 newtons going up and 25 newtons going down. What's going to be my resultant force? 25 minus 15, 10 newtons. Going in which direction? Up to down. Let's calculate my acceleration. My resultant force is also 10, my mass is also 1, so my acceleration is also 10 meters to the second to the square 2. But what's the direction now? Up to down. So even though I have the same number as the previous one, my direction is different. It's going down now. And the last example, I have 25 up, 25 down, and 15 going to the left. What should I cancel? 25 up, 25 down, cancel each other. So my resultant force is 15 newtons. In which direction? From right to left. And my acceleration is going to be 15 equals to 1 times A. So my acceleration is going to be 15 meters to second to the power of 2. And which direction? Also right to the left. In conclusion, acceleration is also always in the same direction as the resultant force. Okay, in summary now, the larger my net force, my resultant force, leads to larger acceleration. So the higher my force, higher my acceleration. But the larger the mass, it's going to be a smaller acceleration. So if I increase my mass, my acceleration decrease. And my resultant force, how do I calculate? Mass times acceleration, or can I calculate the direct deceleration? So I just need to divide my force by my mass. The direction of the acceleration is in the same direction as the net force. Okay guys, that's it. Thank you so much for watching, and please answer the questions in the form, okay? Thank you.